Yes, thank you, Eric. I am Emmanuel Delaroche from the French Paying Agency, from the ASP, and I am the coordinator of the NIVA use case about agri-environmental indicators that we are going to present. I will make a very short presentation, and I will let the floor back to Eric, who is from the INRAE, and who is the scientific coordinator of this use case. Actually, Sen4CAP is used in several NIVA use cases, and for this purpose, an agreement has been set up between the two projects. The objective of the use case developed here by France is to measure the impact of agricultural activities on climate and environment. The basic idea is to develop environmental indicators that can be calculated all over Europe thanks to IACS data and Sentinel data provided by Sen4CAP particularly, and needed from, in some cases, some additional data as pedoclimatic data and FMIS data if they are available. ASP and INRAE and IGN has developed a multi-actor approach in order to select the relevant indicator and then develop the needed software, process the indicator in different areas and countries, and discuss the results. So may I let you the floor, maybe for the remaining slides?
Thanks. Yeah, thanks a lot, Emmanuel. So INRAE proposed a selection of 13 candidate indicators. They were discussed with some key stakeholders, and we finally selected 3 indicators: carbon storage, nitrate lixiviation, and biodiversity, since they address 3 of the 9 CAP objectives. And those indicators may be computed at different tiers, so levels of complexity. The tier 1 approach is easy to obtain, but is of course less accurate. It's based on some empirical approaches. The tier 2 provides better results, but it is more difficult to get because often it requires some access to FMIS data, but it is also based on an empirical approach. And finally, the tier 3 approach provides best results, but is less operational currently. So, concerning the carbon indicators, the demand in NIVA was to have the possibility to calculate them based on the Sen4CAP and also in the standalone mode. So we started to develop first a tier 1 approach to calculate from the Sen4CAP NDVI products some maps of net annual CO2 fluxes. So it's not a carbon budget; it's one of the components of 3 components to calculate the carbon budget. And the tool is now operational, and it has been tested in other member states, in Spain, in the Netherlands, and in Denmark, and in France, of course. And then to be able to calculate some crop maps, it's the tier 2, some carbon budget crop maps, it's the tier 2 approach. We need some connection with the FMIS through an API, and that's something that we will develop this year. And last, for the tier 3 approach, we developed an end-to-end processing chain that is called AgriCarboneo, that integrates a radiative transfer model to calculate the leaf array index that is then assimilated in a crop model called SAFI-CO2 that allows to estimate the CO2 fluxes and the crop and cover crop biomass production. And this information is then injected in this FMIS interface in the tier 3 calculator that contains a soil module, and that allows them to produce some pixel scale carbon budget maps, as you can see on the bottom right. So right now, yeah, and of course, as the idea was to be able to connect those tools to the Sen4CAP through an API, we could inject the daily fire index produced by Sen4CAP directly in the SAFI CO2 model to produce the tier 3 maps. Right now, we focus more on the tier 1 approach because it is the more advanced and operational one. The idea was to estimate empirically the net annual CO2 flux at parcel level, which is related to the number of days of vegetation, as you can see on the figure on the left. This method is valid only for on arable land, but for most of the main family crops that we can find in Europe, except rice. The idea is that we can see, calculate this duration of vegetation cover based on the NDVI time series, and then apply this linear relationship to calculate the CO2 fluxes. So with EGN, the group developed a tool in Python, which is very easy to install, and there is an executable file to run the tool after just filling a few elements in the window that opens, like where is the file, what is the NDVI threshold you want to define, and what is the duration of the period on which you want to do the calculation. So it's very, very simple to use. It has been tested in those different areas. So in France, as you can see, in Spain, in the Netherlands, and Denmark. Denmark is about to be done. Sorry, we start to have some.
It's already done, Eric.
It's already done. Okay, perfect. It is very soon. Okay, thank you, Emmanuel. So we started to produce some maps of the net annual CO2 fluxes. We have two examples here: one in Spain, close to Seville, and one in France, in the Ain department. And what you can see on those figures are when the plots are green, it means that they are fixing CO2, which is good for the climate. When they are yellow, they are close to neutrality, and when they are red, they are emitting CO2 over annual cropping year. As expected, we have here this plot that shows that for different crops, either if they are fixing or emitting CO2, so the orange boxes represent well, in the middle you have the median of in the middle of those orange boxes that represent the median for the CO2 fluxes for a given crop, and then the size, the height of the box gives you an idea of the variability for each crop concerning the CO2 fluxes that we could observe. And as you can see, sunflower is most of the time emitting CO2, which is logical because it has a very short vegetation cycle, and other crops like barley, for instance, or wheat are fixing annually some CO2. We did the same analysis in France, and as we have a cooler climate compared to Spain, the vegetation cycles are longer, meaning that they absorb more CO2. There is a rather strong variability, for instance, in maize, that is caused by the fact that for some of the crops, it could be only maize grown during the cropping year, or maize plus a cover crop, which explains why we have such large variability in the results. We started to work on the other environmental indicators. So the one concerning the risk of nitrate leaching will be coded soon in the AgriCarbon EO processing chain, and will allow to calculate some risks, some indicators at the plot scale. The principle is quite simple. Based on the IX data, we identify which crop was growing on year N, and from there we calculate a mineralization coefficient based on the crop residues. And we look at the crop for the following year, based also on the IX data. And we identify with the Sentinel products if there is the presence of a catch crop in between, and from this we can calculate some nitrogen uptake during the cropping year or during the sensitive period for nitrate leaching. It is an approach that was developed within the frame of another European project called the Diver Impact. And the tier 2 approach is the same as tier 1, plus it accounts for some climatic data and the type of catch crop, if we can have access to that through the FMIS. And last, concerning the biodiversity indicator that will be tested very soon now in France, it is an indicator that is applied at landscape level. In the tier 1 approach, the idea is to estimate what is the proportion of semi-natural habitats around the farm and to compare, in fact, the elements, the surface with crops, artificial surfaces of the farming system together with what is present in the landscape around it. So it's some kind of comparative analysis between the farm and the landscape. And in the tier 2 approach, we have the proportion of the semi-natural habitats, but also some information concerning the type of some semi-natural habitats. For instance, if we have woods, ponds, some edges, etc. And tier 3, it's a bit the same thing, plus we could have access to some FMIS data concerning the pesticides. So we are still working on this last indicator now. To conclude, we have now worked on 3 indicators that are addressing 3 categories of environmental issues, ecosystem services that could be implemented operationally at pixel plot or landscape levels. They are based on the Sen4CAP standards for most of them and developed in open source for the 3 tiers. Tier 1 can easily be implemented everywhere thanks to the IX data plus the Sentinel data or Sen4CAP products. And Carbon Tier 1 is available on the GitHub on the NIVA website, and it was successfully tested in several countries now. And the other tiers are under development, and they will be soon available. Also, tier 2 and 3 will offer higher level of accuracy, as I was saying formerly, but they will require some additional data like FMEIS or climatic data. So in the end, the Sen4CAP API could be used to calculate, for instance, the carbon and nitrogen indicators through the AgriCarbon Hero, and that's something that we will have to implement in the coming months. So thanks for listening.
Thank you very much, Eric and Emmanuel, for this interesting presentation and other perspective of what is done in the project, but what can rely on what has been done on the project.